Hey everyone, welcome back to How to Hub. Before we dive into today's incredible industrial tour, I need you to imagine something for a second. We live in a world that's literally built from steel: the buildings around you, the car outside, even parts of the device you're watching this on right now. But here's what's going to blow your mind: most people have no idea how we actually transform raw materials from the earth into the strongest building material our civilization has ever known. Today, I'm taking you inside one of the most impressive industrial facilities on the planet, a massive steel production plant that produces 3.6 million tons of steel every single year. That's enough to build thousands of skyscrapers. And trust me, you need to stick around until the very end, because I'm going to show you something that will completely change how you see the steel around you every day. So let's start this incredible journey at the very heart of steel production, the blast furnace control room. Walking into this facility is absolutely mind-blowing. We're standing in front of these massive blast furnaces, and the scale is just ridiculous. These aren't just big machines, we're talking about industrial giants that operate 24 hours a day, 365 days a year, only shutting down once every 15 years for complete rebuilds that cost tens of millions of dollars. The control room itself is fascinating: two separate control stations monitoring two blast furnaces simultaneously. There's a specialist operator for each furnace, plus a process supervisor overseeing the entire operation. And here's something incredible: this never stops. This is a continuous process that's been running for decades. Now let me show you the raw materials that go into this process. This is iron ore that's been processed into what they call sinter, these man-made pellets that look almost like clinker from a blacksmith forge, but they're actually iron ore that's been specially prepared for the blast furnace. Then we have coke, not the drink, but coal that's been processed to remove impurities, leaving almost pure carbon. The blast furnace itself is an absolute monster. We're talking about a structure that's over 100 feet tall with a diameter of 32 feet. And here's where it gets really wild: they're forcing hot air and oxygen into this thing at about 3 bar of pressure through 30 massive pipes called tuyères. Each of these tuyères is made of 100% copper, and here's why that's brilliant: even though copper has a lower melting point than steel, its incredible heat conductivity means that water cooling can pull heat out of it much more efficiently than steel or iron. So these copper injectors can sit inside the furnace at its hottest point without melting. The temperatures we're dealing with here are absolutely insane. We're talking about 2000 degrees Celsius being pumped into the furnace. At these temperatures, the carbon from the coke reacts with the oxygen in the iron ore, stripping away the oxygen and leaving us with molten iron. But here's what's really incredible about the scale: when they tap the blast furnace, molten iron flows through channels carved into the ground into these things called torpedoes. Each torpedo holds 350 tons of molten iron. That's like 700,000 pounds of liquid metal being transported by rail to the next stage of production. The smell, the heat, the sulfur in the air, it's like being in the world's most massive blacksmith workshop. You can feel the industrial power all around you. Now here's where it gets even more impressive. That molten iron from the blast furnace, called pig iron, isn't actually steel yet. It's full of impurities like excess carbon, sulfur, and phosphorus that need to be removed through refining. The torpedoes carry this molten pig iron to the basic oxygen steel plant, where they tip over and pour 350 tons of molten iron into ladles. These ladles are absolutely massive. The mechanical arm on one of these ladles is 20 feet long, and it moves 400 plus tons of molten metal like it's nothing. First, they desulfurize the molten iron using a lance that injects powdered reagents and nitrogen gas. Then comes the really spectacular part: they use oxygen lances to burn away excess carbon and other impurities. This creates these incredible controlled explosions inside the furnace as the carbon gets incinerated. After the basic steel is made, it goes to what they call secondary steel making, where they add the final alloying components. This is where they can create specific steel grades, adding chromium for stainless steel, manganese for strength, or silicon for specific properties. Every addition is calculated down to fractions of a percent because that tiny difference determines whether you get steel for a paperclip or steel for a skyscraper. Once the steel composition is perfect, it goes to the continuous caster, and this is where the magic really happens. Picture this: the ladle full of perfectly alloyed molten steel at 1560 degrees Celsius gets positioned over this machine. The steel flows through a hole in the bottom, goes underground through water-cooled copper molds, and emerges as a solid steel slab. But here's what blew my mind: this process is incredibly fast and efficient. As the steel moves through the system on water-cooled rollers, it's still partially molten in the center while the outside has solidified. An automatic flame-cutting head cuts 10-meter lengths, and each of these sections weighs 30 tons. A single casting line can produce enough steel in 1 hour to build several cars. The slabs come off the line still glowing at 700 to 800 degrees Celsius, and they get transported to the hot rolling mill. This is where the real shaping begins. In the reheating furnace, cold slabs take about 3 hours to heat up to rolling temperature. Then they go through this incredible process where massive rollers, some weighing as much as school buses, apply thousands of tons of pressure per square inch to shape the steel. What's absolutely mind-blowing is watching 40mm thick steel getting coiled and uncoiled almost effortlessly. These coiling machines handle what looks like it should be impossible, taking thick steel and winding it up like a garden hose to save space in the factory. The steel gets passed back and forth through these rolling stations, each one making it thinner and controlling both thickness and width to create the exact specifications needed. Hot rolling happens while the steel is still red hot, which makes it easier to shape but creates a rougher surface. Later, cold rolling at room temperature requires enormous force but creates that smooth, precise finish you see on cars and appliances. Here's something that really impressed me: every 2 to 3 hours, the rollers themselves are so worn from processing steel that they need to be completely replaced. The entire floor shifts on hydraulic cylinders, old rollers get removed, fresh ones get installed, and all 7 stations get new rollers fitted in just 7 to 8 minutes. The precision and efficiency is incredible. Throughout this entire process, they're continuously monitoring the temperature of the steel and adjusting water sprays to make sure everything is just right. The final product, steel strip that gets coiled into these massive coils, might be the exact same piece of steel we watched being cast just minutes earlier, but it's traveled several hundred meters through this incredible industrial process. What really struck me during this tour is the people. Everyone we talked to genuinely loves what they do. We met people who've worked there for 17 years, 28 years, with fathers and grandfathers who worked at the same plant. It's literally in their blood, generations of families dedicated to this incredible industrial process that creates the material our entire civilization depends on. The scale of this operation is something that just won't come across in a video. When you see a 20-foot mechanical arm moving 400 tons of molten metal like it's nothing, or watch 30 tons of steel being shaped effortlessly by machines generating pressures that could flatten a car, you realize you're witnessing one of the most impressive industrial processes humanity has ever developed. From iron ore and coke going into the blast furnace, to molten pig iron being refined into steel, to continuous casting creating solid slabs, to hot rolling shaping those slabs into the final products, this is the incredible journey that creates the steel holding up every building, making every car, and forming the backbone of our modern world. So what did you think of that incredible journey through steel production? Which part of the process amazed you the most, the massive blast furnaces, the continuous casting, or those incredible rolling mills? Drop a comment below and let me know. If this behind-the-scenes look at industrial manufacturing blew your mind, smash that like button to help others discover it too. And definitely subscribe to HowToHub and hit that notification bell because we're taking you inside more incredible industrial facilities and manufacturing processes that will change how you see the world around you. Trust me, you don't want to miss what's coming next.